Start. The theme of World Water Day 2025, a day observed every year on March 22, was glacier preservation. The year 2025 has also been declared the International Year of Glaciers Preservation by the United Nations. March 21 is World Day for Glaciers, observed for the first time this year, which also marks the beginning of a decade of action on cryospheric science 2025-34. There have been a series of global events on various issues that have included the theme of water and glaciers, from science to policy, and the need for regional and local actions. The United Nations World Water Development Report 2025, which was on the theme Mountain and Glaciers Water Towers, has drawn global attention to the importance of mountain waters, including alpine glaciers, in the sustainable development of mountain regions and downstream societies. This focus is relevant especially in the context of a rapidly changing mountain cryosphere, which will have a profound impact on downstream water resources. The cryosphere concerns the frozen portions of the earth. The year 2025 is also the midway point in the United Nations Decade of Ocean Science for Sustainable Development 2021 2030, which proposes the vision of science we need for the ocean we want. Rising coastal and marine pollution, coastal hazards, rising sea surface temperature, and sea level rise, and the loss of marine biodiversity are the subjects of concern that have been highlighted in this ocean decade. Water connects both these geographical entities, as there is a clear upstream downstream linkage. Human activities upstream impact the downstream environment, although the hydrological cycle operates independently as a natural process. At the subsystem level, it is modified due to human activities. These include damming and the diversion of water from rivers for agriculture and other purposes, the drawing of water from surface water bodies and groundwater aquifers, and the pollution of water bodies. All these changes result in the alteration of fresh water flow to coastal areas and the open ocean, thereby affecting the marine environment. Current water management practices often overlook this linkage, which is now emerging as a major global concern. in recognition of the need for integrated land, fresh water, and coastal ocean resource management. The concept of a source to sea approach was proposed as a part of the Manila Declaration in January 2012. This declaration focuses on furthering the implementation of the Global Programme of Action for the Protection of the Marine Environment from land-based activities adopted by 65 countries. It proposed to improve cooperation and coordination at all levels to deal with issues related to oceans, coasts, islands, and their associated watersheds by applying integrated management such as RIS to reef approaches, including by involving stakeholders and developing innovative solutions to improve or resolve identified problems. The Stockholm International Water Institute also launched the Action Plan platform for source to sea management initiatives on September 1, 2014. The aim was to help decision makers, stakeholders, and freshwater, coastal, and marine experts to connect, cooperate, and promote better practices and also facilitate and enhance international cooperation. Since January 2025, the International Union for Conservation of Nature hosts this platform. The basic premise of the S2S approach is the understanding that Earth is a unique system and the fresh and marine water systems are part of a single continuum. This approach takes a critical view of current water management and governance arrangements, which use different strategies for different segments of the same water body. In 2012, the analysis report of the Land Based Pollution Sources Working Group, United Nations University, suggested two major adjustments for the approach to project management. The first was to overcome the traditional divide of water, or rather, the isolated consideration of rivers, aquifers, lakes, large marine ecosystems, and open oceans. The second was to apply a socio-ecological system scale in design and scientific analysis, including trans-boundary diagnostic analysis and causal chain analysis to arrive at solutions. Both these suggestions deserve the attention of all countries. The working group was executing a project of the Global Environment Facility International Water Science to enhance the use of science in international water projects in order to improve project results. India faces several challenges in the matter of water management. These include spatial heterogeneity in the availability of water, unequal access, increasing pollution, climate change, and conflicts. A Niti Aayog study reported that water stress might affect 600 million people with a likely loss of 6% of GDP due to water stress. The Aqueduct Water Risk Atlas of the World Resources Institute observes that India is one of the countries which could face extreme water stress, impacting agricultural production and disrupting the economy. In 2022, the Central Pollution Control Board identified 311 polluted river stretches of varying severity along 279 rivers in 30 states and union territories. India produces an average of 1.7 lakh tons of solid waste a day, of which around 53% is treated. A significant amount of untreated waste finds its way into water bodies. India uses an average of 60.5% of extractable groundwater resources, with states such as Haryana, Punjab, and Rajasthan reporting more than 100% use. Around 25% of groundwater assessment units are under various categories of risk. Over 60% of irrigated farming and 85% of drinking water are derived from groundwater reserves. Groundwater quality is also declining. Water security faces a growing threat. India's water management problems are a result of a fragmented and sectoral approach. Another reason is because rivers and other water bodies are often interstate and multiple political jurisdictions are involved in administering the same water body. There are four different governance systems to address natural commons such as rivers and water bodies. Private property owners operate on the local panchayat village governance commons. Local government operates on the state governance commons. The state government operates on the national governance commons, and the national government operates on the global governance commons. The challenge is to coordinate activities under different tiers, have them as a part of the nested governance systems, and devise an appropriate water policy for the country. The first national water policy was introduced in 1987. Subsequently, there have been attempts to modify and include other features. In 2015, a committee was constituted to restructure the Central Water Commission and the Central Groundwater Board to form the National Water Commission. In 2019, the Ministry of Jal Shakti set up a committee of independent experts to draft a national water policy. It has suggested policy recommendations to address challenges. States have also prepared water policies. Despite these initiatives, the S2S approach has yet to gain the attention of policy planners. There are two case study initiatives being contemplated following the S2S approach. The first address the nutrient management of Delhi water bodies. under the S2S platform, and the second is a proposed project under the S2S Future program to examine relationships between human settlement and the S2S landscape in the Indo-Gangetic Basin. It is important to have a shift in favor of the S2S approach, adopting a social ecological system framework for coordinated implementation of the fresh water and marine sustainable development goals. The focus must be on linking targets 6.5 and 14.5 by involving all stakeholders, reducing the gap between science, policy, and execution, and facilitating innovative interventions.